All right, let's do another one. Okay, so read it twice, think about it. You're driving a car at 75 kilometers per hour. There's 25 over the posted speed limit. You see police car, slow down to 45. Over a distance of 88 meters. What's the acceleration? What's your elapsed time? Okay, so everybody draw your motion diagram and draw your pictorial representation. When you have that done, so stop your video. When you have that done, come back to the video. All right, so here you go. So this is one-dimensional motion, but it's horizontal. So I'm just doing the regular thing, positive to the right, negative to the left. How many points do I need? I only really need 2 points. I need the starting point is going to be when you slam on your brake. Well, you don't slam. When you start slowing down, when you hit your brake. That's the initial point. And your final point is when you finally reach 45 kilometers per hour. Okay? So all you need is 2 points, right? You don't need anything before you hit the brake. Who cares? Okay? So this is where you hit the brake. You're going at 75, and here's where you finally reach 45. Okay? Now, obviously you're accelerating, correct? And you're going in this direction, but you're slowing down. So what do you learn? If you're going in that direction, you're slowing down, what's the direction of the acceleration? Opposite, right? Opposite. So I was actually a slacker. No, I wasn't a slacker. So here's the motion diagram, right? So, okay. So you're going fast, slow, slow, slow. So acceleration points that way. So there's the beginning, the end, acceleration points that way. So what has to be the sign of the acceleration? It has to be negative. So again, that's awesome because for part A, if you get an acceleration that's positive, you know you're wrong. So all of these things are just helping you get the right answer. All right? Okay, you need 3 points. 2 points, 2 points. X0, V0, T0, X1, V1, T1. A. All right, let's do it. So what are you going to call this? 0, why not? Okay, we'll call it 0 meters. So X0 is 0. Now look, I was super lazy, right? So X0 is 0, T0 is 0. So I was super lazy. X0 equals T0 equals 0. Didn't even write units. Horrible. Okay, what's V0? 75 kilometers per hour. Uh-oh. As soon as you see that, 75 kilometers per hour, what do you realize? You're going to have to convert that to meters per second, right? Because everything that we do is, kilograms, meters per second. So you're going to have to convert that to meters per second. Okay, X1, it says it took 88 meters. V1, 45 kilometers per hour. We've got to convert that to meters per second. And what do we want? We want the acceleration, which is going to be negative. That's why this is nice. And we want to find the time. All right? Okay, so, okay, now, I'm not going to do it. I want you to do it, okay? You're not going to learn how to do these by watching Brother Weber all day long. The only way you're going to learn how to do it is for you to do it. So make sure you get this correct. You know how to convert these, so convert these to meters per second. All you have to do now for part A, you just look at the equations. This is not free fall, so you don't look over here, right? Look over here. Right? So you just find the correct equation for part A for acceleration. And then for part B, you want to find the equation with a time in it. So you do that. And however, I'll give you the answers, okay? So these are the answers. So the acceleration is minus 1.58 meters per second squared times 5.28 seconds. Do these make sense? Well, okay, it has the right sign, has the right units. You should ask me, Brother Weber, how do I know it's minus 1.58? I don't know, but all I'm saying is not like a million or 1,000 or 0.001. This is kind of a normal, regular number, Okay, how long should it take? Yeah, 5 seconds. Is that normal? Is that sort of common sense? Yeah. It's not super small. It's not super large. So all I'm saying is you always want to ask yourself, are these reasonable, All right. Okay, so make sure you know how to do this, because you're going to have those on your homework problems and on your exams. All right, let's do another one. Well, you're doing it. But. Okay, number 3. Bob throws a ball straight up, 20 meters per second. Now this is a little tricky here. There's a little curve ball. He releases the ball 1.5 meters above the ground. Right? What's the maximum height of the ball? And then, what's the ball's impact velocity as it reaches the ground? Okay, now a couple of things here, you know. Notice it's velocity. It's not speed, it's velocity. So we have to get the correct sign. So if it were me, I would underline or circle velocity, you know. Okay, so I'm picturing that in my head. I hope you are too. Now pause the video and draw the motion diagram and draw the pictorial representation. Now, for the pictorial representation, how many points are you going to need? Well, I'll show you in a minute. Okay? You need 3 points, right? Because, well, okay. First we'll do this, right? Okay, I don't really need this. What? Plus, plus, you didn't see that, right? That's a mistake. Oh, gosh. Right? That's plus, that's minus, sorry. Don't see that. But all we care about is up and down, so minus, plus. Okay, we begin here, 1.5 meters above the ground. Slower, 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 stops. And then it goes down, faster, 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 faster. So there's a motion diagram. Okay, we really need 3 points. So here's the ground. And again, you label it however you want to label it. So here's the point where it starts, 1.5 meters above the ground, right? Y0, V0, T0. Then it stops here, Y1, V1, T1. And then this point is that point. And then it goes, here's the ground, Y2, V2, T2. The acceleration is just gravity, minus g, right, with the correct sign. Okay, so you want to find the, okay, what's the maximum height? That's y1. And then we want the velocity when it hits the ground. That's v2. All right, so you work on this. And again, if you want to work with other people, that's great. So here are the answers. Do they make sense? Well, you know, she's throwing at 20 meters per second. That's kind of fast, right? So it's going to go almost 22 meters high. And then the velocity is going to be minus 20.7. Now, here's something important. Here's something really, really important. So here's the ground. Okay, the ball leaves here at 20 meters per second. So, right? Okay, what we want to find is the height, the impact velocity as it hits the ground. So right before it hits the ground. So here's something that you always want to check yourself on. Remember, this is free fall. There's lots of symmetries with free fall. If I drew a horizontal line right here, what would be the velocity right here? Well, you know, minus 20 meters per second, right? Now, so therefore, what's the velocity going to be here? It has to be going faster than 20 meters per second, right? Because it's accelerating. So all I'm saying is, if you had velocity equals minus like 15 or 19 or 10, you know it's wrong. Because it has to be going faster than 20 meters per second. So you kind of always, when you're doing a word problem, you always want to think of things like this. And it will help you to avoid making silly mistakes. All right, so you two, you work on examples 2 and 3. Make sure you get them right. You have the answers. If you have any questions, you can contact me. But I'd actually prefer you to contact our tutor, who is Litian, because he needs to make money. He's only going to make money if he gets people to call him. So call him, and he'll help you. Or work with other students in class. That would be great. All right, let's review. Motion in 1 dimension. Again, later on we're going to be doing 2 dimensions, which is just more of this. Okay, so we learned how to describe problems in different representations. We did motion diagrams, we did pictorial, and we did the equations. We talked more about position, velocity, and we learned about acceleration. We used kinematic variables to describe motion. We learned the Randy Knight problem-solving strategy, and we're learning to solve problems. Okay, let's just review a little bit more. Okay, we're finding position from velocity and time. That means if somebody tells you the velocity in time, you find the delta x. So this is the equation that works for constant velocity as well as changing velocity. For constant velocity, the area under the curve is just a rectangle. For changing the velocity, this thing is just, it's not a rectangle, right? It's just the area under the curve. And in lab, I think you'll have a lab where the computer can calculate that for you. You have to know this. Acceleration delta v over delta t. You just have to know it. We learned that when the velocity and acceleration have the same direction, which means same sign, either both positive or both negative, the speed increases. When they have opposite sign, the speed decreases. Again, we'll be using that the entire semester. Okay, so these are the kinematic equations for constant acceleration. So these are just the general ones. You know, either for x or y, you can change whatever you want. These are just free fall. So all we did, we just replaced the y with the x, with the x with the y, and we put a ay equals minus g. So these are free fall equations. So you'll use these equations for the kinematic problems. And again, the Randy Knight problem-solving strategy. Make sure you read this whole thing, please. And that's it. So we're done chapter 2. Thank you very much.